Okay, so let us start with the first numerical test of this chapter. Okay, light class 10. We'll start with question number 2, textbook page 177. So let's go and see that question number 2, textbook page 177. Let me read the question. Look into your textbook as I read. The radius of curvature of a spherical mirror is 20 centimeter. What is its focal length? So here, very clearly we see that R is equal to 20 centimeter, which is the radius of curvature. Okay, radius of curvature. Now we don't know whether it's plus or minus because they just said spherical mirror and they didn't tell us whether it's concave or convex. That's why we should not put a sign here, right? Then the question is saying, sorry, what is its focal length? That means small f is question mark is the focal length. So write it down. Now in doing numericals in this chapter, we need to keep these formulas. There are 5 formulas, okay? Thoroughly memorized, and anytime ready for you to retrieve from your memory, okay? So, which is the formula that is going to apply in this case? R and F. This is the second formula only, right? F and R. So let us take that one. We know that F is equal to half of R. We have discussed this in our previous classes, that the focal length is always half of the value of radius of curvature. So that is equal to half into R is 20 centimeter, right? So here 2 1s are 2, 2 10s are 20, so 10 centimeter. Therefore, its focal length, if you like to mention, F is equal to 10 centimeter, our answer for the first one, okay? Now next, let's go into the next one, question example 10.1. So example 10.1, this we'll find on textbook page 179. So go to that page 179. We'll do slowly, and it's important now to remember the sign conventions and those 5 formulas there. Okay, let us go and read 179. A convex mirror was used as a rear view mirror on an automobile, that means a vehicle like a car, has a radius of curvature 3 meter. If a bus is located 5 meter from this mirror, that means this is the mirror of a car, let us say automobile, the driver is using, and behind this car is another bus. So the bus, it's not a bus mirror, the bus is the object of the mirror of the car, okay? So if the bus is located 5 meter from this mirror, find the position, nature, and size of image. So we have to find these 3 things: position, nature, and size of image. So for this, let us draw a rough mirror, which is not necessary in exam. With your pen itself, you can draw it. Convex, very clearly. So let us draw the mirror. And in your rough, you can just draw this because this helps us. Okay, let us just write what is given in the question first. Write down, since the question is saying, since, okay, the convex mirror, the convex, we'll just write in short, convex mirror, used as rear view mirror, forget about that, has a radius of curvature. This is exactly from the question only, curvature of 3.00 means 3 only meter. So let us write here before that, and we can just write here and another information is given. Next sentence, bus, okay, bus, you can write in all your bracket if you want. This is extra we're putting. Bus is the object behind the car mirror. Bus object is located Let's do slowly. It's quite easy if you do that. 5 meter, 5.00 means 5 meter only. From this mirror, that means the mirror of the car in front, this one convex. So this much information is given to us. So with this, let us draw a rough mirror of this car, the car mirror, not the bus. Bus is the object. So it will be like this. We know that our mirror should be face convex, means bulging outside is reflecting, facing left, always sign convention. Just now we discussed. So the center is, the ball is like this, means see here, half of that is F and this is P. So this is the car driving in front of the car mirror. The bus is behind, means left side of this mirror. So let us say this is the bus. This is the bus. Just draw it roughly, means the object. Now we need not draw this in exam. Once you get so comfortable, if you don't want, you don't need to draw. But if you draw, it really helps you, especially in the beginning. Okay. So this object should be on the left. We discuss the sign convention right now. So this car is driving in front, and behind it is this bus, and the image of the bus is on the mirror. Okay. So here, this distance here, according to question, the distance between the bus, which is the object, and the mirror, means P of the convex mirror of the car in front. Automobile means car in front. Distance between the object bus and the car mirror is 5 meter. See here. So it's on the left, so minus. Okay. Then the convex mirror has radius of curvature 3. And we know the radius of curvature is the distance between C and P. Between these two, the distance between C and P here. Radius of curvature. So this radius of curvature is 3 there. 3 meter, the question is saying. It's on the right side clearly, so R is going to be plus. Only these two information are given. So by using this information and from our knowledge of sign convention with the help of this diagram, we know here we can write very clearly here. This is nothing but distance of object. You know is U is minus 5 meter, right? And then here, because you can write your object distance, means distance of the bus from the mirror. Then here, this is nothing but distance between P and C. Radius of curvature, capital R, is plus 3 meter, because this is called the radius of curvature. Okay, these two are given. So if R is there, we must involve F, because only then we can use that F in this mirror formula, main one. So immediately you can write down, since, you can write your since, okay, F is equal to half of R. We know this formula. So F will be equal to half into R is just now 3 meter, which is equal to 3 by 2 meter. So we got our F also, and we have U and F R also. So if you have U and F, now what is the question asking us? Let us go and see. Find the nature, find the position, nature and size of image. So position means position, nature and size of image. So position means distance, position of image means distance of image from the mirror, which is V, you know that. So V is what the question is asking, image distance. Image of the bus distance from the mirror. Then nature means, the best way to find out nature is M. There are other ways to find out, but I find that finding M to know the nature is more complete, okay? So let's find out M. Nature will be told by M. This is nothing but your magnification value. Remember that M tells you the nature of the image form. Position, nature and size. So size of image means HI, which is the size of image. Then HO has to be involved. This is size of, because if HI is there, we have to involve HO because the formula relates to that. Okay, so these are the ones. These three, especially position, nature and size, these three is what you have to find using the help of HO. Let us start now. Now look at this choice of formula, all the 5, and you see that U is there and F is there. See, In this mirror formula, U and F are there, means immediately you can find V by using this formula. So you write here, since 1 by V plus 1 by U, we know is mirror formula 1 by F. So mirror formula main one is this one. So 1 by V we don't know, plus 1 by U, do slowly, minus 5. So let us just put here minus 5 meter. If you want, you can put bracket by 1 by, and this line should be longer, okay? 1 by, then F is here, 3 divided by 2. This main line should be longer. Meter is here. So we can now find V slowly. So here, 1 by V. Then when we have double sign like this, we can multiply them. Plus and the minus. Yes, that's right, minus. And that minus, which is in the denominator, can be now brought up, okay? Because that's the more comfortable way of doing it. And here, 1 into means down 2 will go up. 3 meter, even meter is on the numerator, will come down. So 3 meter will come down. So you get here 1 into 2 by 3 meter. This is 3 by 2. So now we can write here, that implies 1 by V is equal to here 1 into 2 by 3 is simply you can write 2 by 3. Please notice that meter is in the denominator, okay? Minus 1 by 5 we shift to the right side from left. Sign will change to plus 1 by 5. Even meter is in the denominator. Let's do slowly. Then here as we continue doing, then that will be equal to, that implies 1 by V will be equal to 3 and 5 LCM we know is 15. So let's just write there 15. Then here, and meter should be there. So 3 5s are 15, then 5 2s are 10. Plus 5, how much is 15? That's right, 3. So 3 1s are 3. So we're going to get here 1 by V is equal to 13 divided by 15 meter in the denominator. 10 plus 3, 13. So if you cross multiply this one down and up, you will get 13V. Then put equal sign. Then we know that up and down again 1 into 15 and 15 meter. That way we can just write V is equal to, and here 15, we write that one, divided by this into means 13 will come to denominator. So this is the value of V. Let's just keep it as 1. Later on we can deal. So here V is 15 by 13. We already got this position, we finished. Then we'll go to nature, which is told by M. So let us go and do that. So as we continue doing this, we're going to get here, since formula for M, there are 2 now. M equal to HI by HO, but the value of HI and HO are not given. 2 centimeter, nothing is given about HI and HO, so we cannot use that. So we have to go to next. V is there, just now we got. U is there in the beginning, right? We got there, see, minus 5. So we can use that formula. So the right formula now to use is M is equal to minus V by U. Okay, now as you write this, next step will be equal to minus, you write down and then put here long line first. Then this minus is that of the formula, okay? Then go to V. V here is 15 by 13 meters. So let us write there clearly on the numerator, 15 by 13 meter. This line should be long enough. Then U is here, see, minus 5. So we write that minus 5 down. Meter also, don't forget. And this minus and minus will cancel. So you're going to get 15 by 13. And here meter, just write it. Into means we know 5 meter by 1. So 1 by 5 meter. 1 will go up and 5 meter will come down, because changing this long line divided by into multiplication, then that will happen. This meter and meter cancel. 5 3s are 15, right? So we're going to get here equal to 3 by 13. And there is no unit. Please remember, M will not have never have unit, because it's a ratio. Meter by meter will cancel, no. So M can never have unit. So that is the value. Now let us divide this one. 13, 3 is divided by 13. So 3, 0 point, then here 0. 13 2s are 26. Okay, and then here 4 remainder. Okay, and then we can just write here 4 remainder, and then point means 0. 13 3s are 39. So we can just go up to the second place. Okay, that will be enough. I think textbook is also doing up to second place only. Some people go to third place, but you can just write here 0.23. This is the value of m. Let us put this one as equation 2. So the nature also we can now find out. But before we go to size, I want to explain something, side note. So in the next page of your copy, you write down this one, the explanation for m. Okay. Now you see here, there are 3 cases possible. So write down case 1. Now case 1 is, we'll make it very clear. Object is HO, size of object is, let us say, 5 centimeter. Then the image formed by that mirror, let us say, we know is denoted by HI. So same size, 5 centimeter. So both are 5. Okay, so do that. That means very clearly we can see the size of object and image are same size, 5 centimeter tall, 5 centimeter tall. Then what happens to m? We know m is formula HI by HO basically, as you can see here, right? So this is 5 centimeter by HI is 5 centimeter by HO also 5 centimeter. So we can very clearly see here that this will cancel and you'll get 1. So what do we write here? When m is equal to 1, like in this case, size of image, we know that image is size of image is the same as size of object. So when we solve a numerical and we're getting m equal to 1, be sure that size of image and size of object are equal. That's what m tells us about the size of image. It doesn't tell us the exact size, but it tells us the relative size. That is, whether the size comparing image to object, are they equal or taller? Image is taller, image is diminished. So that's why m is very important. Case 1 is m equal to 1, then size of image equal to size of object. It can be 5 centimeter, 5 centimeter, or even 10 centimeter, 10 centimeter. Case 1. Okay, case 2. Let us go and do case 2. Write down this one on a new page, so you keep this one always in mind. Case 2 possibility is this one. Size of image object, let us say, is 5 centimeter tall. But size of the image is much taller, let us say, HI. Formed by the mirror is called image size, is 10 centimeter. Then what will we get? And m will be equal to what? HI. I will not write the formula anymore, I will just use this HI. Okay, just write HI by HO. Then 10 centimeter divided by 5 centimeter. So that is 5 2s are 10. So m will be 2. That means we see that when m is greater than 1, 2 is greater than 1 now. When m is greater than 1, image is magnified. Remember that now. Magnified. We're trying to get these keywords. When is it magnified? When is it same size? You can round it like that if you want. And circle it, I mean. The third case possible, the last case, case 3 possible is like this. Size of image object, let us say, is 10 centimeter. The size of image is smaller, let us say this time, HI equal to 5. Then m will be what formula? That's right, HI by HO, right? So how much will this be equal to? That will be equal to, HI is here 5 centimeter divided by 10 centimeter. So we cancel centimeter, centimeter. We didn't cancel 5 2 because 10 is very easy to divide. So you'll get here equal to, divided by 1 0 means decimal shift from here to here in left side of 5. So left side of 5 means here. 0.5. So here we see m is clearly less than 1. 0.5 is less than 1. No? Grade 2 is greater than 1. So grade m greater than 1 here. M less than 1. When does this happen? So when m is less than 1, just write like that. When m is less than 1, like this, image is what? Image is diminished. In other words, it's smaller than the object. These are the three cases. Same size, image magnified, then m always greater than 2. Image diminished, image is shorter, then always m less than 1. Keep that in mind. Okay, now with that, we're going to discuss the nature later on. That's why I'm saying. Okay, now I'll wrap it out and we'll continue with our numerical. We got our V, position of image. We got the M, so we're going to get the nature. And finally, the size of image, which is, we write here, since we know HI by HO is equal to M. M equal to HI by HO, or HI by HO equal to M is same, right? So that gives you HI by HO. We don't know nothing about this. M just now we got 0.23. And you can write here, since using equation number 2. So that gives you HI equal to 0.23 into HO. So we cannot get a real size of image, but we're getting a relative size. So we're going to write that. Okay. So let us write this one as equation number 3. Now let us start writing the answer. Go back to question. Position first, then nature and size. Position, nature, and size. So position means V. So let's write V. We got here. No sign means plus 15 by 13 meter. So let us divide this. 15. Now finally in the end we divide it. That's the better way. Okay. 5. 13 ones are 13. 2 remainder. 0.0. 13 ones are 13 again. 70. 13 fives are 65. So we can stop there. Okay. 1.15 at the back. So up to second place will be enough. So there will be approximately plus 1.15 meter. Comma you write here, which is positive. We have to use the sign conventions. Okay. We have learned sign convention means left side measured minus, right side is plus, above principal axis is plus, below principal axis is minus. So we're going to apply that. So if V is plus, what does it tell you? Therefore, position of image. So we can write here, answering the first question, position of image of the bus on the car mirror. Position of image is 1.15 meter, comma, plus means we know now, behind, sign convention, you remember, or we can also write in bracket, behind or right behind the convex mirror. Plus is telling out that the image is behind or right side of the convex mirror of the car in front. Okay. Okay, so that is the first answer. The next, nature. We learned that M will tell you the nature. So M is equal to, just now we got here, plus, no sign means plus 0.23. As you get this one by using equation number 2, and we forgot to write here, but you also write here, since using equation number 1, we got V value. Okay. Then here we can write down, therefore, which is, okay, using equation 1, which is what? Which is positive or negative? Yes, very clearly positive. Plus, nah, positive. And compared to 1, the number 1, is it greater than 1 or smaller than 1? Yes, and smaller, or yes, lesser than 1, smaller than the number 1. Positive will tell you something about the nature. Positive means what? M equal to positive. Do you remember? In the sign convention we discussed in the previous class. Positive means image nature. Image is virtual, comma, erect. When M is positive, image is always virtual erect. Minus means really inverted, right? Virtual erect. And the value is smaller than 1 means just now case 1, 2, 3. Smaller than 1 means image is, yes, diminished. So the size of the image of the bust will be much more smaller than the actual size of the bust, diminished. So that is the nature. So that also answer, position answer, nature answer. Now size finally. So let us write it down. Size means HI. So you write here, since we know HI is equal to here 0.23 times HO, as you get this one by using equation number 3. Therefore, okay, we can write here size of image is 0.23 times the size of the, what HO means, object. We cannot get the real size, so if the question is asking size means we can just tell you the comparative size in terms of HI and HO, because they did not give us HO value also. So that ends this question. So we have done these two here in this class. In the next class we'll do the next 3 numericals. So it will take 2 classes to complete this 10A part, okay?